In this video, let's look at using the delay function in the EaganMatrix. Now, a simple way to hear what this is doing is to create a noise hit, some kind of percussive sound that's very short, and when we throw that into the delay, you'll easily be able to hear what's going on. Let's create a formula. We'll set this up to multiply by a value 0.5 on Z, and what we'll do now is we'll set this to a shape generator, set it to a pulse. We'll create a pulse of noise by setting the shape generator to, let's say, a fast value, or not terribly fast. Let's try 18 times a second, and we'll gate that, and now we'll put that value as a noise input to the Big Bank, and we can set that Big Bank frequency up on X and throw in a few simple parameters that should allow us to get a percussive like sound out of that. Here I'm going to set the bandwidth to 0.7. I don't want to set it too low. I won't get the percussive sound I want. This can go to 1, maybe 0.9. Alright, let's see what that sounds like. We'll throw the output of that to A and press the fingerboard, turn our display on so we can see what's going on. Let's try that. Obviously, we set this up to continuous. Let's set it single cycle because we want to create a single pulse when I press the fingerboard. That should be very good for us to determine what's going on when I send it into the delay. So now we're set up. Let's talk about the voice delay. That's the default when you bring up the EaganMatrix. The manual tells us the voice delay provides a multi-tap, we'll see what that means, audio delay buffer separate for each voice. Voice delay is suitable for creating chorus and flanging effects and can be used for fast slap delays. Let's use it. We know that we're sending our percussive output to the A bank. Now we're also going to send that value to the voice delay. I'm sending the unity full amount, but I could send less if I wanted to, and very often you'll want to send a small percentage into the voice delay and not have your delay as strong as your main output, but we're going to want to accentuate that delay so we can hear what's going on. Now the first parameter is the delay time. 0 is no delay, the default, and 1 is the max delay amount that's noted in your delay time selection. That in this case goes from 50 milliseconds up to 6.4 seconds. We'll set that at 100 milliseconds for now. So I've sent that value into the voice delay, and let's delay for the whole time 100 milliseconds. I could, if I want to, set that to 0.5, and that'll basically delay for half that time. Let's go back to the full time. Now what I'm going to want to do is I have the original sound coming out. I will normally want that, and then I'll want to send the delay out as well. So I'm going to send the delay, which is bank C, out with it. I'll send it out actually higher in volume than what's being sent out as the main outputs. And now I should hear a double attack. The initial sound plus the delay 100 milliseconds later because I set it to that full 100 millisecond amount. There it is. Here's my delay. If I wanted to, I could set this to the smallest value, and that should be twice as fast. And if then I want to make this 0.5, that should be even faster. So fast, if I make it small enough that the output and the delay will overlap on each other, almost creating a double hit. I think you get the idea there, and I could set that back to 1 now, and maybe for 400 milliseconds. There we go. And we can set it to 800, twice as long. You can hear, even though I've set the output for the delay to be higher than the main output, as the delay gets longer, the copy comes in a little quieter. If I go to the next setting, it's more obvious. The delay alters it a little bit. Now let's go back to 800 And now let's talk about the taps. The taps are 4 more possible copies of that delay that can be sent to the outputs. Here on the AES input, there are options for tap 1 and 2, and on the sub output there are options for tap 3 and 4. You don't have to use all 4, you can just use 1. You can use all 4, you don't have to use the main delay going to output. I could just use the taps if I want to, but we're going to use them all together here. So what we'll do to allow you to hear this pretty easily is I have the unity value, which means the full amount of delay is coming out. I don't want to set all of my taps to that same value. Well, let's try it. Set them all, again, higher in volume than the main output. And let's set everything to 1. So I'm setting the same full 800 milliseconds on each tap for the delay. What's that going to sound like? Obviously, I have 5 delay copies here, but they're all set to the same value. Let's change that. We'll set my first tap to be, say, 0.8. Then we'll set the next to be 0.6, and then the next to be 0.4, and then the next to be 0.2. So what I'm really doing here is I'm making the delay faster for each one of the taps in succession. I'll have the main output sound, I'll have my main delay coming out. I don't have to, but I'm having it here. And then I'll have all the 4 taps that will come out in succession because their delays are all different. I should then get 1, 2, 3, 4, 5, 6 attacks coming out. And that's exactly what I hear. 1, 2, 3, 4, 5, 6. And I can play around with these values, obviously, to do anything I want with. I can have the first one come in a little faster. They don't have to be even. Then I can have this one be a little higher. And there's a way that you can get some nice rhythmic changing patterns coming in by fooling dynamically with these tap values. So I've set things back so that the delays are all in even multiples of each other. And now let's talk about the remaining parameter, this hold parameter. What this does is it stops recording new data into the delay if the value is greater than 0. What might that be used for? Let's create a formula on B where I'm going to have the lower half of y less than 0 and the upper half of y will go greater than 0. So as long as I'm playing on the bottom half of y, if I apply that formula to the hold parameter, I will get the delay copies that I expect. Now if I play in the top half of y, I'm only going to get the original output without any of the delays because that hold parameter is greater than 0. And you can see how you might use this dynamically in a preset to turn on and off the delay based on pressure or based on Y or some other formula that you might want to construct. The next thing to discuss about the voice delay is this delay column in relationship to the tap. The taps represent a percentage of the D column. So if I turn the D column off, remember we have them all on now and equally spaced again. If I turn the D column off and take that delay away, I'm going to take all the taps away too, because the taps are a percentage of what's in this D column. And then if I make the D column half of the 800 milliseconds to begin with, then my whole grouping is going to be twice as fast as it was at the beginning. So we have a couple of ways then to change the speed of the delay. One is to actually play with the delay speed itself. Then the other is to set the fractional percentage of that delay that you want to use that can make it come out even faster. But if I set this to a value more than 1 and set it back to my original 800 milliseconds, that kind of distorts the pattern a bit. This is only supposed to go to 1. Obviously, if I set it to other values, I'm going to get unpredictable results. So you shouldn't set the D column to more than 1. Let's look at a couple practical examples from the presets. one that will use the basic voice delay and another one that will use the voice delay with taps. The first example is from the synth category, the swept delay preset. This, as you can see, is not too complicated. We'll go through it in steps. The first step is a simple oscillator set to a sawtooth-like wave and sent through the digital reverb to the outputs. There's a little bit of convolution interpolation set and wet-dry mix of the convolution set as well. What I've done here is remove the settings that don't apply to the step I'm talking about. So here we have just a simple oscillator sent to the outputs with some recirculator control. Just a simple oscillator. Step 2. Now you can see it's getting a little more complicated. That oscillator, which was sent out to left and right through the black lines here, now it's also sent into a voice delay set at 400 milliseconds. And the output from that is sent in parallel to both a low-pass filter and a high-pass filter. Those filters are set to the maximum cascade of 48 dB per octave and extreme update rate. There's going to be a feedback loop added here, so we want that update rate to be set to maximum. Both of these filters use a cutoff using dynamic control of both Z pressure, and also there's a shape generator set to a very slow sine wave that's 90 degrees out of phase in one filter and 180 degrees out of phase in another. So there's some motion going on in the cutoffs. And the bandwidth of those filters is controlled by X using a base value of 0.25. So there's a pretty low bandwidth set on both of these filters. The low-pass filter gets sent to the left output, and that shelving high-pass filter gets sent to the right output. So here is the oscillator getting sent into the voice delay through just Z pressure, and that voice delay is being sent through those high and low pass filters out the left and the right channels. So if I press on the fingerboard now, you should be able to hear, faintly you can hear that little delay echo. All that's being done here right now, you can't really hear too much. If we want, we can turn off the main oscillator output, and let's listen to what the low-pass filter sounds like. You can actually hear the delay now from when you see my finger press. There's the low-pass filter. Let's turn that off. Here's the high-pass filter. You can hear the difference there. So Ed is differentiating a little bit in the sound that's going out to the left and the right channels here, which is lower than the sound going out from the main oscillator. Now this is called swept delay, and part of the reason for that is we see there's a shape generator set to a very slow value. Once every 10 seconds this will go through its cycle. And if we listen to that, let's turn off the main output and just listen to the filter. You can hear that slow sweep of the filters going on there. It'll be much more accentuated, say if I set that to once a second. And of course if I set it much higher, it'll start wobbling. Now perhaps you might want to change it to something like that, or a value in between, to get a different sound out of this preset. Now the third step is to send a little bit of that low pass and high pass filter output back into the voice delay. There we go. This is identical to what we had before, only now 0.01 is being sent through the voice delay, so there's a little feedback loop going on there that's not that perceptible at this stage. If I set this higher, and you got to be careful here, if I set it too high I'm going to create a feedback loop that's going to get out of control. But if I set this to something a little higher, now I play. Hey, you can kind of hear that feedback going on there. I'm not going to have to do that here because, as it turns out, the next step is to turn on a major feedback. And now we'll look at the final step in the equation of creating this preset, and that's the voice delay itself is looped back on itself to create this feedback path that is controlled by a barrel. When the barrel's at minimum, this feedback path is off. When I set that barrel to the maximum, I'm going to get an infinite feedback loop going on. So here I have my output of the voice delay, and you can see it's being sent back in on itself with this formula that has a multiplier based on the barrel times a value that's controlled by Z pressure to the 0.5 power. What will this sound like? Right now it'll sound like it did before because I have it off. Let's turn on a little bit of that feedback. This sounds best when I do a little glissando. You can hear the feedback starting to come in. Let's turn it off. And let's turn it up to like halfway. An easy thing to do by just looping the delay back in on itself. Let's go all the way up to infinity. And that'll just keep looping on itself. And there you have the basics of the preset, the delay that's doing what we talked about before, with the added benefit of adding these feedback loops on itself that create that wonderful, continuously changing and echoing sound. But you got to be very careful that you don't send the wrong numbers in on these feedbacks. If you send stuff in too high, you're going to create overload in some cases, and you're not going to like the result. Let's take a look at another example that uses taps. This time it'll use the delay in a very subtle way to impart a little bit of shimmer and sheen, as opposed to the last example where the delay was used for a massive effect. This preset from the synth pads category is called Waterphone Strings, and it's a little more complicated than the last preset. Let's take it through its steps. The first thing that this preset does is it takes some very low noise and sends it through a bandpass filter with a fixed cutoff to the outputs, as well as an oscillator set to a sawtooth-like waveform that's dynamically controlled a bit, and that goes through a fixed low-pass filter to the outputs, again using a reverb very much like the first preset. Here again I've turned off things that don't apply to the step I'm talking about, and here's the sound of the oscillator going through the low-pass filter and the noise going through the bandpass filter. A stringy kind of sound that's half string, half oscillator. The next step is to take that low-pass filtered oscillator and also send it into a voice delay. And this time that voice delay sends the main delay plus 4 taps to the outputs. And those taps are set so they all are controlled by a different shape generator at a slightly slow moving frequency that differs for each one, and each is 90 degrees, not 45 degrees, out of phase. Let's look at that. So here I've turned on the delay and the taps and the shape generators, and you can see the oscillator that's being sent through that filter to the outs is also being sent partially into the voice delay at 50 milliseconds. And each one of those taps, you can see, is set to one of these shape generators moving at a slightly different slow rate at 90 degrees offset from each other. Let's turn off the main outs of the filtered noise and oscillator and just listen to the delay. Let's turn up the volume on that. You can hear its very slight motion, a kind of overlapping vibrato that is being created from those shape generators all coming out at slightly different delays. Now I could, for example, make it very much more noticeable by making one of these a multiplier of 2, maybe 4, maybe 8, and now you'll see a real overly accentuated motion. We don't want that, but you get the idea of what these shape generators are doing. Now the final phase of this preset is to take a second oscillator, again a saw-like kind of sound, that's sent through another shape generator to impart a little bit of vibrato on it, and that's sent into the voice delay as well. Another voice sent into that voice delay, and that's going to be treated like the other input, all sent to outputs through the main delay and taps. So there's our final preset. This second oscillator that you can see is controlled by a little bit of frequency modulation added to the X component, and then that is sent at full amplitude into the voice delay with the other voice we had in there, and that is going to all go through that path that we talked about before. Let's turn it up to full level so we can hear it. We'll remove the main sound right now, and so there's our little shimmering vibrato that's being added through these taps and delay. We can turn on everything now, and you can hear the final sound. That's it. A very subtle use of delay and a really ostentatious use of delay.